Working around, so I have to be able to control it.
Yeah.
So we're live now. So
Okay.
Let's get started. So welcome everybody. Today we have the defense presentation of Miss Fernanda Weiss for her master degree in computer science. Her advisor is Professor Marcelo Mendoza, and now we introduce the committee. So we have Dr. Dennis Parra from Pontificia Universidad Católica de Chile. We also have the invited committee members, Professor Evangelos Milios from the Dalhousie University. And I myself, I am also the internal evaluator for this exam. And Dr. Marcelo Mendoza is the advisor, and I am also the president of this committee. So now, Fernanda, you have 30 minutes for your presentation without interruption, and then we will proceed to a round of questions from the committee members, and then we will give to the public, which is live on YouTube now, the opportunity to ask questions, and then we will go to deliberate, and then we will come back to give you the final outcome of this. So now, please, 30 minutes, go.
Okay, thank you very much. So, good morning, professors and the audience. I'm Fernanda Weiss, and I will present my thesis project entitled Fake News Detection with Language Agnostic Features. So, we all know that today we live in a different society than 20 years ago, specifically because of the role that social networks play in our daily lives. They have changed the way we communicate and interact. Social networks are so integrated into our modern life that 30% of people who interact on social networks do so more than 10 times a day. And due to the ability to break the limitation of the physical distance, social networks are an ideal platforms to accelerate the dissemination of information. Hence, these platforms are favored spaces for the dissemination of news of all kinds, even those that are false. And due to the large amount of news that circulates on social networks and the effects that they can generate on us, it's important to have automatic mechanisms that allows us to identify those news items that are false, since humans' capacity is limited and we cannot study thousands of news per day. In the literature, this problem has been widely studied. We divide these studies according to the features that are used. So a well-known data source is content-based features of the news. Some study more specific approaches within the text, such as part of speech, name of entity, and even stenographic or psychological analysis. Another data source is that which uses properties of news propagation called context-based features. In general, these features are used alongside the context-based features, and they are used to support the text analysis. Thus, some studies use temporal information to order the comments of the news item, and others just add information of the users or properties of the spread of news through the social networks by embeddings. And other studies use only the context-based features. One study used the user profile information sequenced according to the order of the messages issued by those users. And another approach is the use of information that can be represented as time series using the time series classification techniques. And this approach inspired this project. So, in this project, the hypothesis is that it's possible to improve the performance of the fake news classification on social networks only by using the language agnostic features. Therefore, the main objective is the design and implementation of a fake news classifier based on language agnostic feature of a social network, and we have specific objectives such as determining if a news item is fake or not without using the text of the news, compare the performance of the proposed method with methods of the state of the art, and document and generate open source code that is on GitHub. So, for this project, we will understand a news item as an assertion made on social networks, and a rumor as a social phenomenon of a news item that is spread through the social network. And based on this, we model the rumor data as follows. We have the S, which is the set of the news item. C is the sequence of interaction of the news items S. In such a way, the interaction of the news item SI are in CI. Then the X, which is the set of indicators. The indicators are the signals captured from the news item, which means that those are the perspectives in the study of the news items, which are the posts, retweets, replies, the volume of interaction, the different users who participate in the spread, and also the followers and friends of users who participate in the spread of the news item. And finally, we have the set of prediction of the classes. In this study, we work with 4 credibility classes: non-rumor, which is factual information; true rumor, which is true information; false rumor, which is false information; and unverified rumor, which is not feasible to determine its truthfulness or deceitfulness. So we constrain the problem to be solved using only the feature extracted from C. So a news item is characterized through a temporal fingerprint that are univariate time series. So to build comparable temporal fingerprints, we use a fixed length time series in which a sequence of interval is defined, where L is the length of each temporal interval, and N is the number of intervals. So then, a temporal fingerprint of a news item SI is conditional to an indicator from the set X by the counting of the number of interactions of CI created using the indicator X that belong to each temporal interval. Okay, sorry. And finally, with this, we have a representation for the news item SI, which is given by a stack of temporal fingerprints corresponding to a multivariate time series. It's possible to apply different preprocessing blocks to the time series. However, there is no consensus on which is the best way to preprocess. A block is the time series augmentation, which allows us to create more time series examples using the pooling and noise operators. Other blocks is scaling, which allows us to bring the time series to the same comparable domain. It could be the min-max scaler or standard scaler. And another block is piecewise aggregate approximation, which allows us to reduce the dimensionality, helping to the runtime. So, with the stack of temporal fingerprints as the representation of news, we use a science neural network, which has 2 inputs. The reference input S1 and the example input S2. And the task is to determine how similar they are. In this case, the reference input corresponds to a prototype of news, and the example input to a news item in evaluation. So here we solve a subtask, which is learning the prototype of the news by each credibility class. So for this, we propose 2 approaches. The first one is based on clustering algorithm. The model with this approach of learning prototypes is called PSN, which has 2 steps. The first one is the temporal fingerprint clusterings that aims to divide a set of n temporal fingerprints or univariate time series of the same indicator into k disjunct clusters. To solve this task, we use a version of k-means feasible to work with time series. So in this case, k-means uses dynamic time warping as the distance metric and dynamic time warping barycenter averaging as the average metric. The second step is the news item clustering that aims to divide a news items into L disjoint partition. But how? We already have k clusters of the temporal fingerprints by each indicator, right? So if we overlap these clusters, we can see that a news item could be part of more than one cluster. So the behavior of multiple assignments of a news item is represented by a hypergraph, where the vertices are the news items and the hyperedges allow to model the relationship between the training set examples according to the class member team and the temporal fingerprints clusters. So here we look for an optimal partition of the hypergraph that divides the news into L partition. Then the second approach of learning prototypes is based on deep learning clustering. The model with this approach is called PSN plus SV. We use the Zombie model that learns discrete time series representation, and the author found that such representation improved the performance on the clustering task. So we use it to get the clustering of news items. Zombie is a neural network that combines a variational autoencoder architecture with a self-organizing map and probabilistic models. Zombie works with multivariate time series, and the clustering is on the self-organizing map. And finally, to get the prototype by credibility classes, we assign the class of each partition or clustering according to the majority class of news it contains. Then we calculate the barycenter of each cluster with DBA, getting the prototypes. To identify the similarity between a news item and the prototypes, we train a prototype Siemens network. So we have the S1 input and S2 inputs. Then we encode both inputs using the same de-encoding network that is a feed-forward network of 2 layers with shared weights. After passing through D, both encodings are in a latent comparable space, where we calculate their Euclidean distance. And finally, if the distance is small, it means that both inputs are similar, so S1 and S2 belongs to the same class, and Y is 0, and otherwise Y is 1. We use RMS probe as an optimizer algorithm and the contrastive loss as the last function, which is inspired by the matching task and is used on the Siemens network. Therefore, the model learns to align the news items with the prototypes of the same class and learns to misalign them when they do not belong to the same class. The final stage of the model is getting one of the 4 credibility classes for a news item. So when a news item's example comes, here we pair it with each prototype. Then every input pair is evaluated into the prototype Siemens network, getting a similarity of each input pair. And then a multi-layer perceptron network receives as input the similarity information among the news items at the prototypes, and the output is one of the credibility classes. In this way, the outcomes of the Siemens network are aligned with the classes of the task. We evaluate the proposed model over 2 real datasets, Twitter 15 and Twitter 16. These datasets contain the propagation path of the news item with the timestamp of interactions. And in this table shows a summary of datasets. It's important to note that even though we have about 1,000 of news, we work with many more examples to train because of the pairing with prototypes. The configuration of the proposed models is as follows. For the encoding network of the Siemens network, we use 2 hidden layers with 32 and 16 units, 50 epochs, and a batch size of 64. For the final classification, the multi-layer perceptron network uses a hidden layer with 32 units and an output layer with 4 units corresponding to each credibility class. And the optimizer is ALM, and the last function is categorical cross-entropy. We split the data into 3 sets: training, validation, and testing, with 60, 20, and 20% respectively, and randomly from the total data. The results are combined from the test set, are obtained from the test set. Then the experiments are over the first 12 hours of the propagation path of the news item, with a time interval of 10 minutes and using a sliding window. And depending on the proposed method are the indicator used for the temporal fingerprints. So in this way, we use 5 of them for PSN and 7 for PSN plus SV. And the preprocessing for the temporal fingerprints is a min-max scaler and the PAA blocks. Depending on the dataset and the method is the number of prototypes required. So on Twitter 15, 30 are for PSN and 20 for PSN plus SV, and on Twitter 16 are 40 prototypes for both methods. So the first experiment that I show you is the comparison between the proposed method and the benchmark method. We divide it into 2 groups. The first one contains methods that use context-based features, mainly methods of the time series classification area. And among these classification models, the PSN, the proposed model, is the best and reaches a good F1 score on the false rumor class. So here we can say that PSN model outperforms the state-of-the-art of time series classification, which is considered FCN. Then we go to the second group, which contains methods that use content and context-based features. These models are in particular from the fake news classification area, where the recursive model, the TD-RVMN model, is considered the state-of-the-art. Among these methods, the recursive model is the best, with a performance of 71% of F1 score. Also has the best performance by class, except of the non-rumor class. And also, if we see the general results in this group, we can see that these models have at least the same performance as PSN, the best model of the previous group. Then we evaluate the time-sensitive performance over the best model of each group. So here we show the results of PSN, the best model of the content-based model group, and the TD-RVMN model, the best model of content and context-based models group. Here we change the time base and analyze the first 3, 6, 12, 24, and 48 hours of propagation of news items. We can see that the recursive model here is better than PSN model at every moment. And the recursive model, has an increasing curve through the time, unlike PSN that while observing the propagation in a longer time windows like 24 or 48 hours, the classification performance decreases. We can explain this due to the time series. The interactions are concentrated at the beginning of propagation. So then, when we analyze a longer time, like 48 hours, all the activity is in the head of the time series, and in the tail is almost empty. So far, the proposed method is not a good classifier. The performance is inferior to the recursive model. So we wonder if including the text of news is decisive to get a competitive classification performance. So in this line, we propose a hybrid method as shown in this figure. So on one side, we work with the PSN model that uses the time series. And on the other side, we work with the recursive model that uses the text. Then we can concatenate both embeddings and use a multi-layer perceptron to get the final classification. Now, we evaluate this hybrid method and compare it with PSN and the recursive model. The performance of hybrid method is superior to both methods, reaching a 79% of the F1 score, which means that overcomes the state-of-the-art in 14%, and also improve the results in every class. Now, we evaluated over different time bases, and the results are in the curve with the cross mark here. At every time, the hybrid model is the best, even in the longer time windows, where despite seeing decreases in performance, this is not too much, because the text balances out. And finally, I would like to show you 4 prototypes of temporal fingerprints of the volume indicator. Each prototype represents a credibility class. So here we can see different patterns. In the prototypes of true rumor, the indicators are in the earliest stages of the propagation. For the false rumor, it's possible to say that it keeps the activity through the propagation. And the pattern of non-rumor is similar to a true rumor, having more activity in early stage, but in this case, the fall of the curve is softer. And finally, we have the unverified rumor. They are news that could neither be confirmed or refuted, and they have several time patterns among themselves. They make confusion with patterns from the other class. So here, like we see, where it's similar to a constant activity from the false rumor. So, concerning to the main objective, we were able to achieve it. We worked on a news representation that uses language agnostic features, plus our classifier is based on Siemens network. Due to this, we generate news prototypes by class, which allows us to identify patterns. According to specific objectives, we were able to classify a news item without using the text. It reaches the best performance among the method that uses context-based features for the classification. But if we compare these outcomes with the state-of-the-art of fake news detection, the PSN method is not competitive because it doesn't reach the performance of the recursive model. Due to the mentioned above and the previous work on this project, we reject the hypothesis since it's not possible to reach or outperform the performance of the state-of-the-art of fake news classification with a classifier of language agnostic features. For that reason, we propose a hybrid method using time series representation and the new items text as input, intending to verify the impact of the content-based feature as the text. And for this proposed hybrid method reaches the outperform on 14% of F1 score to the state-of-the-art. So finally, the main contribution of this project are development a method that uses context-based and language-agnostic features, the characterization over time of credibility classes of news items, verify the use of the text of the news item is an important data source for the problem of fake news detection, and development a new model that outperforms the state of the art. As future work, given that the PSN model is at a disadvantage, this is where there is a space for improvement. So one possibility is to change the distance function of the Siamese network for one parameterized suitable for the latent space. And also, it's possible to consider another clustering method for the news. So over this course of this degree, these are my collaboration and publication. Mainly they are focused on social media and deep learning. And these are the references of this presentation. And thank you for your time.
Thank you very much, Fernanda. You spent about 25 minutes, so I'm very happy about that. You used very well your time. Now we go to the round of questions. We will start initially from the most external member to your work, which is Dr. Dennis Parra.
Yeah. Thank you for the presentation. It was very clear.
Thank you.
And very insightful work and all the description that you provided there. Also very good results. I have a few questions. Let me start with the first one is that when you start with this idea of doing the classification with language agnostic feature, which was the main motivation?
Because the NLP area is in general is focused in English model, o sea, in English language. So when we use that techniques in other languages like Spanish, for example, the performance is not so good. And where we work with that techniques in a sensitive problem like fake news detection, this could be super complicated because we need a good performance for the fake news detection in every language. So that was my motivation, but the hypothesis was rejected. So
okay,
here
so
we are.
In a way,
Your
conclusion is that this is a difficult problem, right? Because
yeah.
Probably you need to build a good representation learning for language and combine that with language agnostic features in order to have a good performance, right?
Right, exactly.
Okay. So the other question I have is regarding what you mentioned as the state of the art. You mentioned the state of the art many times. And I think that is the FCN, the fully connected network, right?
In the time series classification area. So first I compare with this area because I use time series representation. So I use a technique from this area and this state of the art. So I use my time series with FCN, and the performance is worse than my proposed method, PSN. But when I compare the same model, the PSN, with a model of fake news detection area, my model is worse.
Okay. The other thing is that when you do a Siamese network, you need to that thing I missed a bit because you mentioned the use of prototypes and you have to do pair learning, right? Contrastive learning. You have to find pairs of items and then you are representing them with the Siamese network with share weights. you calculate the distance, then you go through this contrastive loss. But I guess that you don't use all the possible pairs. You have to really sample pairs, right?
Yeah,
How is that sampling process in the contrastive learning network?
So for that, I generate a balanced data sets. So I have the same examples for the positive relationship when y is 0, and negative examples when when we have a relationship between the inputs. So I have a prototype, and I pair it with n examples of the same class, and then
the cluster, right?
The same. No, we have a prototype.
Yeah, but the prototypes comes from clusters.
Yeah, but the cluster has a class, so the
okay.
prototype belongs to a class. So we have a prototype of, for example, non-rumor class. And this prototype I compare with more news items of the non-rumor. So we have n pair of this. And then the same prototype I pair with news of the other classes.
Okay,
so here I have.
Do you have a percentage, a number of pairs that you produce, or it was how did you choose that number or that percentage of samples that you needed in order to train well this network?
So here I use 10 for each partition, for say, for 10 for the positive examples and 10 for the negative examples. So how we have a lot prototypes and a lot news items for the permutation, we increases the examples. So with that number is enough. It was enough.
And you trained this from scratch, or you had some pre-trained weights in a way?
No, from scratch.
Okay. So if you go to the results,
which one?
I think maybe that one, yeah, because you have first the previous one, the table. Yeah. So here you have a very good results actually with the prototype Siamese network, but in the case of I mean, yeah, considering only context-based, right? And comparing with the others. But you don't have that very good results in true and in unverified. What do you think you could have done with this Siamese network in order to maybe improve those results?
In some time I tried to increase those examples, but the performance was not very good in those classes. The true rumor, yeah, increases a little, but unverified rumor, not so much. This is a difficult class. Sorry.
Okay. So in that particular case, you didn't have a very good performance, even changing certain hyperparameters.
Exactly.
Okay.
Exactly.
So one thing on your work is that you have, in a way, finally kind of representation learning, right? You take these features that represent a news. You try to represent this in a different space, in an embedding, and then you try to use that representation in order to do a classification. So if you go, for instance, to slide 25, here you have like examples of prototypes, and one might not be true exactly, but one might say, well, you know that false and unverified rumors prototypes look more similar among them than, let's say, false rumor and true rumor, or unverified and true, right? So my question is that if you check, since you were doing these embeddings, that the representation that you were learning, which were closer? You know that you can do these embeddings in 2 dimensions with TSNE or with UMAP, and then you can see these classes are closer to each other or look similar, the representation, and these other look way farther. Did you do such analysis, or did you think of that?
No, really, I didn't think in that, but I know that how you said, the unverified rumor is the complex class, and it's super confusing because some of them like false rumor in general. So here is a confusion. And also, how you say the true rumor and non-rumor are similar in the prototype, but the main difference is the fall of the curve. In the true rumor, I think that in the beginning, the news is suspicious. There are many interactions. And then when we know that it's a true information, the fall is abruptly in down.
Okay.
But when we have non-rumor, we know that it's factual information since the beginning. So here the fall of the activity is lower, is softer.
Okay, so maybe that's something that you could check later, that if the impression that you see here is then reflected in the final representation that you have in the vectors that you are learning with the neural network, for instance. Okay. So those are my questions. Maybe we have another round. I can make more questions, but so far I'm good.
Sure,
Thank
sure.
you.
We'll have a second round. So now we invite Professor Angelos Milios to ask his questions.
Thank you. Thank you, Fernanda, for the nice presentation and the good work.
Thank you.
So my question relates to, I guess, the reliability of the results, all the results, not just based on your own method. So what is the size of your data set?
Wait a minute. Here. So for 2016, we have this amount of news of propagation path, and that for 2016. But how I said, I create prototypes. So when we pair it by the permutation and all of that, the amount of the data set per pair is is very much bigger.
Okay. So given that you have sufficient data, can you run statistical significance tests to get a feel for the variability of the results? I mean, here you have different methods. You compare them, and you say, okay, so your method, the hybrid method, is 14% better than the second best method, which is the content-based method. Can you think of a statistical significance test that would basically confirm that this large difference is actually statistically significant? It most likely is, but how would you assess the variability?
So, well, honestly, when I review the state of the art, I realized that then 10% or even 15% of increases of the performance, it was a lot. So when I get best results, I said, well, according to what I saw in the state of the art, these results are very good. It's a good increases. So I use that to say that it's a good increases of the performance.
Yeah, I don't disagree with that, but I'm asking this question, like if you wanted to do a statistical significance test, how would you set it up?
Really, I don't use another significant statistic.
Okay. All right. So my second question is about the use of clustering to come up with prototypes.
Which approach?
The clustering approach to derive prototypes. So can you describe the clustering process through an example? What exactly is being clustered?
Yeah, so here we have the all-time fingerprints, right?
Yeah.
So the time fingerprints are the univariate time series. So first, we clustering that time series, the univariate. And when with Kamins, we get the K clusters. So then we know that every temporal fingerprint is related to an indicator and also to a news, right?
Yeah.
So if we overlap these clusters, we have then one news. It could be part of more than one cluster of temporal fingerprint by each indicator. So for example, one news, it could be part of one cluster for the retweet temporal fingerprint, and also it could be part of the other cluster when we use the post temporal fingerprint. So this behavior we can represent it in a hypergraph where the news are the vertices and the hyper edges are represented by these temporal fingerprint clusters. Okay? So then with that relationship between the temporal fingerprint clusterings from Kamins and also adding the real classes for the news, we are the partition of the hypergraph. And this partition is the final for get the prototypes.
All right, so you go from the temporal fingerprints, one per feature, I guess.
Indicator.
Per indicator, then you create the hypergraph and you essentially cluster the hypergraph, right? So you have two layers of clustering here. Okay. So how do your so I'm trying to get an intuitive sense of what these prototypes are. Okay. So how do the different indicators come together in a prototype?
Sorry, can you repeat, please?
Yeah. So is a prototype specific to an indicator, or does it combine multiple indicators?
No. One temporal fingerprint is of one indicator.
Exactly.
And then a news is the stack of them temporal fingerprints. So we have a multivariate time series. And then when we cluster the news, the vertices of the hypergraph, then we work like a multivariate time series, like the stack of temporal fingerprints.
Okay. All right. So in the end, what is the prototype? Is it a vector or?
It's a stack of temporal fingerprints.
It's a stack of temporal. Okay. Okay.
It's a multivariate time series which has like channels. If we compare with an image, for example, that's it. But when we feed the Siemens neural network, before to feed it, we use a flattened layer.
All right. Okay. So these are my my questions for now. Thank you.
Thank you very much, Evangelos.
Okay. Thank you very much. So now I giving myself the opportunity to ask questions as an internal member. Okay, thank you very much, Fernanda, for this presentation.
Thank you very much.
It is a very interesting topic nowadays. So
yes,
it is a lot of things that are involved. So my first question it's let's go to slide 27, please, which is the hypothesis, basically. So something interesting here is that you say that you reject the hypothesis, right? But more than reject, you cannot confirm or accept the hypothesis, basically. Which is
yeah.
not the same.
Well, the thing is, yeah, I did a previous work when also I used the time series. And for this, I used another approach where I used, I have here, when I used a FCN model, but after the field, I used a transformation of the time series like wavelet transform and also a Fourier transform. So when I did this previous work, the results are likely the same. I cannot outperform these results. So when I say that I reject the hypothesis, it's because I have two evidence of my work, and also I have the results of the, wait me a minute please, I have the results of this, the context-based feature, where the most of them, all of them except the PPC model uses the time series, the agnostic language features as time series, and also this has a bad performance. So for that reason, I said that I reject this hypothesis.
Okay, but there are still instances of the possible cases one could study. So it's
it could be. I don't say that no one other method could be reaches a good performance, but according to this project and the previous work and the results of the context-based method, I could say that.
yeah, okay. Under those conditions, I think sounds good.
Yeah, obviously conditioned to this work.
Yep. So now let's go to slide 25, which please. So I will ask a simpler question. So how are those time series built to generate these terms, or basically red lines? So at the beginning, so.
Yeah, first, first that prototypes are getting from the clustering approach for getting the prototypes, right? So I use the method that I explained before to Evangelos. So do you understand that?
No, I am asking to the original time series how you generate for the data.
The original, because that are prototypes.
Yeah.
Okay, so I come from here. So first, I define a fixed length time series, a time base, which is the windows where we look the propagation. So for example, in the results are over the first 12 hours of the propagation, the half day of the propagation of a news. Okay? So then over this fixed length time base, I sequence by intervals. I generate intervals where each interval has a length of L, where in the experiments are 10 time minutes. And then I use sliding windows over the time base for create the time series. So in each interval, I counting the interaction of an indicator that I study. For example, the interaction that are retweets, for example, and these retweets, it will be part of this interval that I study in this time. Do you understand?
Yeah, so it's just generating the series based on retweets or another indicator that you define.
All right. So I have the post and the retweet replies volume. So each indicator conditional a temporal fingerprint of a news SI.
Okay. Yeah. Okay. Yes. Okay. Thank you. Now something more generic again. So is your code available for reproducibility of the results?
Yeah, all the Jupyter notebooks, because I work on Colab from Google, because my little computer hasn't GPU, so I use the Colab. And these Jupyter notebooks are on GitHub here. And these are the survey model, which I create the prototype with the deep learning approach. Also, the clustering of the clustering approach for getting the prototypes, and the Siemens network, the proposed model.
So, and the data is also available at the repo?
No into the repo. Are in the original paper where Dima showed to the community. But the thing with this dataset, or with the source of the dataset, is we have the news and the labels for the news, but when we have the propagation path of the news, we just have for each node, or for each interaction, we have the ID of the post, of the user, and the time. So if we want, get the information specifically of the post or of the user, we need to go to the Twitter API for getting. So for that reason, here I use basic indicators, because, for example, here, these 4 indicators, I can getting just from the propagation path. So I don't need information of the user or of the post. But then here, I need the information of the user, but is basic information from that I extract from Twitter, and that's it. So it's not difficult.
Okay, and when you did the comparison with the state-of-art method, you got the data from their works, or you were able to rerun their own algorithm?
No, I rerun the algorithm.
Okay, they were all available, basically.
Yeah, but I don't have in my GitHub. I use another report of this specific method, but I don't add it to my GitHub.
No, but they are available.
They are available. Yeah, they are available.
Okay, and so now we see the accuracy of the F1 score matrix in general. How do you compare your method in terms of computation time to the others? Or the complexity, basically?
Well, when we have the prototypes, it's not too complex. So the main effort is getting the prototypes. But if we compare, for example, for the recursive model, which I say that is my state of the art, for this, first I need the post which has the text. So first, the first complexity is getting that information for Twitter, because in the source of the dataset it doesn't. And then getting that, I need to preprocess and to get the TF-IDF vector representation for each document. So I think that each model has their part of complexity, but according to my times when I ran that method, I could see that my method is a little more complex in time that recursive model, for example.
Okay. And memory usage? You didn't run out of memory?
No, really. No, I didn't have problem with the memory, with none of one. So again, here I use the PSN. First, I generate the prototypes, and then I did the classification. So in both parts, I didn't have the problem with the memory, but these parts were separated.
Okay. Okay, that's for now my side. So now I change my role and I invite
Okay, thank you.
to ask his questions.
Okay. Good morning, Fernanda.
Good morning, Professor.
Hi. I have some questions for your presentation. So I will start asking you about the difference that we observe between the reported results of the state-of-the-art papers and the reproduced results that we got during the experimentation. In general terms, when we reproduce the models using, or in these data sets, the results are, in general, maybe 10 points below the results reported in the papers of these models. I am referring, for example, for the CSI or the recursive model. Do you have an explanation, a clear explanation of this gap between the reported results in papers and the results that we got during the experimentations using these state-of-the-art models?
Yeah, I think that the first one and an important point for this gap is because, how I said, the source of the dataset just has the IDs of the post, the IDs of the news, of the users. So when we go to the Twitter for getting, in sometimes these posts are deleted, or this user has a private account, or this user it doesn't exist. So when we recover the data, the total data, considering the post, news, and also the propagation, we don't have the exactly same data that these models. So this is the first reason for this gap, and for that reason also, I wanted to use some indicators that are easy to get in. They don't change too much the getting of the data source for the model.
Okay, so we have some difference in the data acquisition, and for use terms of the Twitter platform, it is not possible to retrieve the same data streams.
And
that
also,
authors use it when constructed their dataset to report their results. So we have a partial information of the dataset to retrieve or to reproduce the results. So we have a problem of this kind. Okay.
and also I can add something little that is, in general, in this model, and specific in the recursive model, they don't use the retweet. So just use the post ordered by time, but they just use the post. So if one post is deleted from the Twitter, it's super significative for the method, because that is the only source.
But so this comparison is unfair, not for us, just for the. It is very hard to achieve the same results of the papers that are reported in the papers. So because we are working with a partial view of the data. Yeah, so we have many problems. What do you think, or if you have an idea to try to reduce the gap between this result? Do you think that it is maybe a good idea to create a new data set to evaluate, or not? Do you think that it depends on data? So maybe the way to address this is to improve this problem that is based on data, the availability of data set. Do you have to try to reduce this experimental gap? Because if all the methods, all the new methods will have this same problem. It is very difficult to reproduce the results reported in the papers.
Yeah. Well, first, I think that it's necessary to generate or to have more the data set that has the information of propagation path. Because when I start with this project, it was super difficult to get a data set with this information, with the path propagation information. So first, yes, I think that is super necessary more data set with this information are ordering with the time and how this data set has. And for the other side, for get the same performance on the reproducibility, sorry. I think, well, first we need to take an appropriate study of which are the posts that were deleted, or which is the percentage of the total data that we don't have. So maybe there we can to do something like, I don't know, replace with average embeddings from the others, for example, or yeah, something like that.
Yeah, it's a good idea. Yeah, because we have some privacy issues with the data. But if we encode the data set using embeddings, then we can reproduce the reported results using the embeddings. And we are we are in a good way to trying to do this kind of or to drive this kind of things to be part of the new experimentation of this problem. When I read the path propagation classifier, the PPC method, please remember us which kind of information is encoded in this model. Are the authors using, for instance, author profiles data, or they are only using Twitter strings?
No, here they use the basic information of profile user, So they use eight indicators or eight information data, which are like followers, friend, the listed account, if is geolocalized, I think, and this basics information. Then they sequenced these users who issued these messages and sequenced by the time. And with that sequence, they first, well, in parallel, go through the RNN neural network and for the convolutional neural network, and they pass through each one in parallel, and then the embeddings of each neural network concatenate and generate the classification. But this model in their paper, the performance is so good, and they also use Twitter 15 and Twitter 16 with 4 classes. But when I reproduce this method, the results are nothing compared with the paper, the original paper, because they report like 17 or 80% of F1 accuracy. But when I run this method, my result in color, it couldn't reach more than this.
Yes, I remember that they also reported the early detection of fake news using only 5 of the Twitter stream. That is very strange because if you only need 5 minutes of Twitter stream to predict fake news, basically the model is memoizing the user profiles.
Exactly. And also when I reproduce this method, it was a huge problem because, okay, first I reproduce it and I get this accuracy. And then, okay, this is bad. This is not according to the reported by the authors. So then I analyze the data. And when I analyze the data, I realize for example, from the source news or the source tweet for each propagation path, there was a lot of news without the source. So the model just only memorized the source tweet of the propagation path that had. So I think that this method is not too good for that. Just memorize some specific characteristics that some specific news.
So regarding these aspects of the experiments, I have some questions about the data sets. So do you have an idea about the ratio between active users and responsive users in the Twitter streams? Because if we have only a small fraction of active users, maybe some models that can memorize the users will have a very good performance. Do you have an idea about the proportion between active and responsive users in the dataset?
I did that when I studied this propulsive method.
Let me...
but I don't remember it. I don't remember the result.
The definition of active. I mean that an active user is the user that starts a sequence or a sequence of messages. So it's the user that is in the root of the propagation tree.
Yeah.
This is, I'm thinking about active users in that sense of meaning.
Yeah, in the active user is with start the conversation of a news, right?
That's right.
Oh.
We have the balance between active users and responsive users.
Oh, I don't remember how. I show you that in one meeting, if you remember it, but I don't remember the numbers, exactly numbers.
No, need the exact numbers, but just a proportion to give an idea to the audience.
I think that it was like 15 or 20% that the users of the users from the source tweet, it does in the propagation path of news. Yeah, it was something like that.
Okay. So now a couple of more general questions. What do you think that time series plus text improves the models that are only based on text?
Well, how I say, I think that the text it's an important data source. So I think, okay, the time series is a good source, an easy source to get. So with that, we can get a acceptable performance, but it's not too good. But when we aggregate a text, this source it's important because has the sense of the news. This part of the time series part just has the pattern of the propagation, the behavior of the class of the news through the social network. But the text or the text analysis has the real sense of the news. So this source, it's important to determine if it's fake or not. But here I think it could be interesting because in the beginning I said that my motivation for this is that in general the NLP techniques are from English language, right? So we go to the other language like Spanish is not too good performance. So here I would like to experiment with a data set from another language, which is not English, and try with a text embedding or technique for the text that it doesn't reach a good performance in that language, and see how is the pattern of the time series helping to this performance.
Okay. So this result also indicates some deficiencies of the recursive neural network architecture because it is enabled to learn from the volume of the sequences. And this is very
Yes.
maybe
because
with a modification of the architecture that can incorporate the volume of the tweet stream into the representation that is data. This model can do something similar to this combination of two methods with this IRI method. So this is maybe an extension of the recursive neural network architecture.
Yeah, because they delete the retweets, and the retweets are an important data source also for the pattern or for the propagation. So it's an important result. And also, I remember that the recursive model in an extensive paper, they use attention mechanisms. And their results are good, but not too much more than with the basic recursive model.
Okay.
So maybe I think that the include of these other tweets like retweets is the part that they need.
Okay, So thank you, Fernanda. I'm ready with my question.
Thank you, Prophet.
Okay, thank you. So before we go to the second round, I invite to anybody who is connected online to go to the question and answer and to the general public to ask some questions. Meanwhile, we go to the second round. I don't see any questions there. But now we go to the internal second round, starting with Professor Dennis Parra.
Yeah, more a comment than a question. I think it's very valuable that Fernanda has set a GitHub classroom, GitHub repository. But Fernanda, I think that you can do a better job in the README file, because you put files in with the appropriate names, and you more or less follow. But it would be better if in the README you say this project is about this, and you can replicate the results.
You need to do
executing running these files. That's one thing, right? It's quite easy, and you can maybe spend I don't know, one hour and do it quite well. And the other thing is regarding a question that Claudio asked you about the data. I know that Twitter has certain limitations, but you can provide a file with the Twitter IDs. And people can go and download the tweets by themselves. And that's within the terms of service of Twitter. So if you are not providing the data, the text of the tweet, the metadata, that's not a problem. But you have to say, I downloaded, I use this particular tweet ID, right? So that could be super useful, because then you have also more chances to be cited. If you have a good repository and if you have the data available that people can replicate your experiments. That's my...
I will put the link of the dataset source of the Ligma Dropbox, where is the total data of the two datasets.
Okay, yeah, I suggest you that. But apart from that, I have no more questions. I'm good with that. Thank you.
Thank you very much, Dennis.
So, Professor, thank you, Professor Parra, and now Professor Evangelos Milios, if he has any other questions.
Evangelos, I can hear you.
The microphone doesn't seem to be working.
All right. Can you hear me now? Yeah, good.
Yes.
Yeah.
So I wanted to go back to the evaluation of your classifier. So overall, your system and the competing systems are classifiers, right? And when we evaluate classifiers, we try to evaluate on data that has not been used for training. So in your system, especially the one with the prototypes, you have a training part that involves the generation of the prototypes, Chinese networks or the deep learning method. And once you have the prototypes, then you have another classifier, say a multi-layer perceptron, that actually does the final classification. So in the case of cross-validation, you have, say, 100 instances. If you do tenfold cross-validation, you take a random sample of 90 of them, and you train, and then you test on the remaining 10% of the data. And then you change the split, and you essentially generate 10 different experiments where okay, so did you do anything like this in your evaluation? Did you do cross-validation of some sort?
No cross-validation like that, but yes, in each I do 5 experiments for each classifier.
Okay.
So I did 5 experiments for the PSN model, for example. So in that occasion, when the 5 different times that I run, I create a different partition of the train,
Yeah.
and create different prototype for that, and then try and parade it with the test set partition. And every time I did the same process.
But the 5 different, I guess, rounds of training, they're done on completely random selections of training and testing. So,
Yeah, completely.
Okay.
But balance in each partition, I balance the labels.
Okay. So balancing the labels. So the labels, I presume, are highly imbalanced, right?
No, are balanced. Here, for each class, I have like the same examples for
Okay, so,
2016.
all right, so good. Okay, so they are balanced.
Yeah.
Now, one way that you could have used the notion of cross-validation to identify the variability would be to take this, say, if you do 10-fold cross-validation, you have 10 different samples of, say, F1, okay? And you take the average and you put it here as in your table, but you also have the individual samples of F1, right? And that gives you an idea of the variability. So then you could run like a t-test to estimate the statistical significance of
yeah, right. Yeah, it could be add deviation standard or something like that in the results.
Yeah. All right. So that's the yeah. So in your case, you are also training embeddings, right? In order to generate the prototypes.
I train the prototype more than embeddings.
Okay, but in any case, you have another round of training. Okay, so and again, ideally, you don't want any data used for training to also participate in testing.
Obviously.
So I'm not sure if you did that in your experiments.
No, the partition of training is used just for the training, and the testing set is just for evaluate the model in like I show here. So when I say given an example, is an example from the testing test.
Yeah, but so what I'm talking about is the training that you use for obtaining the prototypes. Okay, because you have two kinds of training here. One training that is involved in the computation of the prototypes, and another training that involves the final classification, right?
Right.
So you could. So when you trained for the prototypes, did you use the entire data set, or did you only use the training?
Just the partition of
okay.
training. Yeah,
Excellent. Excellent.
So I divided in training and test, and use the train for all of the process of training, and the test set. Sorry, used just for the given the last performance.
Great. Okay, so so that would be a relatively straightforward way of doing a statistical significance test if you had cross-validation as opposed to random splits of training of data into training and testing. All right. So the other quick question that I have is about this point that was brought up, that you are not able to reproduce the results published in previous work. You were getting less, like lower performance than what was reported in the original papers. And one possible cause of that is that you're not using the same training data, right?
Yeah, also.
Okay, so you started with the tweet IDs, but as we know, some tweet IDs, they don't correspond to actual tweets because those have been pulled. They have been removed from the Twitter data. So you end up testing on different data sets. So the question is, do you know how different the original data set is from the actual data set that you used based on the tweet IDs?
Well, yeah, I have a little intuition about that because how when Marcelo asked me, when I use PVC model, for this model is super important the tweet source of the news, of the propagation of news.
Yeah.
So when I reproduce that method, my results are very lower than the reported on the paper. So there I see some statistics information about the dataset, and I realized that the tweet source is deleted from a lot of the news. So, for example, in that method, that it's super important. It's super significant because this source is basically that they are memorized. But for me, this scenario is not too. It's not too bad because I use just the counting. So for me, it's not important, not too much important that the first source is doesn't a post or the user information because I just counting. So in the indicators of retweets or the post, I have that information. But when I added the time series of the indicator of the followers, for example, yes, there it's important for me. But in the other source of the time series is not too much important. So I think that for that, my method could be reach a good performance because it's information easily to getting from the datasets.
Yeah. But so my question was slightly different. Like when you took the tweet IDs from the previous data set and you went down the list and you were trying to retrieve each one of those tweets, and for many, the tweets had been deleted. So what fraction were the deleted tweets? Is it half of them, or is it like 5% of the original tweets?
No, it could. I think that it could be like, I don't know, 10 or 20%. But honestly, I don't remember fine because this process of the getting the news, of the getting the users and the posts, it was like 2 years ago. Before that, when I go to the Canada, I went sorry to the Canada, so really don't remember, but it wasn't too much like 50%. No, not like that. It was very lower fraction.
Yeah. So in terms of, so this is my last question. In terms of making practical use of your method, is it possible to divide the computation between offline and online computation, and what would be happening offline versus online?
Yeah, in offline we can get the prototypes.
Okay.
So online we just paired this prototype with example of news. So we can get a part of the prototype and maybe update it like one a day or I don't know, regularly. And we can use them for the online part and just pair it, and then analyzing the Siemens network and then in the multi-layer perceptron, and we have the evaluation of the classification.
All right. So the time-consuming part, which is the training, is happening offline, right? So you can take your time to compute, and then you can classify very quickly once you have the whole model trained. Okay. All right. That's it for me. Thank you.
Thank you very much, Evangelos.
Thank you. So it's my turn again. One comment respect to the repository following Professor Parra.
No, I know. I know that.
At least 3 things that should be included, which is the code itself, the script needed to run the simulation, and some comment for the data. Okay, those things are important. And yes, that's basically my question. So I don't have more questions.
Yeah, I know. Honestly, in this time, I focused in the presentation because it's in English and I need practice. So I forget and I forget the data source, o sea, the GitHub. But now I have time, a lot of time, so I fix it.
Sure, no, it's okay. And I will also suggest to add in the repository the links to where to find all the similar algorithms using the comparison. So somebody can continue your work, will get the data organized and start from there. And also, since you use a Google Collaboratory, one could make a file public available with all the configuration files directed to Google Colab, and one could make a local copy right away. So that's also very useful.
Yeah, because I download the notebook and I upload to the GitHub. So it's the same, but I understand your point.
So, Professor Mendoza, last opportunity.
No, just a final question. What was the most difficult part of your thesis?
In the general process or in the practical process of the
in the general
method?
Thinking about the students that are watching this.
Yeah, okay. Well, I think that this is, can you hear me? Because it's, okay.
Yeah, no problem.
So, thank you. Mendoza, Marcelo is freezing. Okay. So I think that in this case, it's an special situation because I did the most of this process in a pandemic situation. So I was in my house, so sometimes I was super productive and super focused, but in other times, especially in the beginning of this pandemic, it was super difficult because something, whatever the thing, but it was super difficult to concentrate. So I think that the most difficult part, it was the believe in me and believe in that I could on myself and believe that I could written this thesis defense because how I said, it was a difficult time for everyone, I think, in our houses, because we here in Chile, Evangelos, we are in quarantine from March. So I am in my house from March. I just go to the supermarket, or that's it. In fact, that's it. So yeah, in this case, I think that was my most difficult part.
Thank you, Fernanda. Let's wait a minute for Marcelo to come back. I think we lost him.
Yeah, I realized that.
During the fight, we lost so we need to wait a few minutes for him to come back. He will make it soon.
And also, I would like to add that it's important to know where stopping the experiment, because we can state to experiment a lot of time, and we need to know where stopping. So that is also an important part to finish this process.
Thank you, Fernanda. Marcelo just made it back.
Yes. Connection was down for a few minutes. So I lost the answer of Fernanda about the most difficult part of the thesis. Could you repeat this, please?
Okay. Well, a summary of that was that for me and for this special pandemic situation, it was the stay in my house alone doing the work, and sometimes I was super productive and sometimes I didn't, because it was a difficult situation. To work with a partnership or with the college, I think that is important, because we can talk about the project, about the advantage, the disadvantage of the method, how improve it. But when you work alone in your house, every day, it's difficult to management the productive time. At least for me, it was like that. So in this special situation, I think for me the most difficult part, it was work in a pandemic. So yeah, and also how I said in the last minute, to know when stop the work, because maybe we can say, okay, here I stop, but then you can realize that maybe you can do a little thing, another little thing, but this little thing is too much time. So it's important to take focus in the time and in the process, in the period of the process.
Okay, thank you.
So we are at the very end. So I am just checking the web page if there are questions from the public, but I don't see any questions. So if any member from the committee has one last questions, it is the time. If not, we will now make a switch. So we will deliberate in private, and then we will come back to the online.
Okay.
So Fernanda, we invite you to disconnect from here.
Okay, so
we'll let you know. I don't know how.
me neither.
¿A sala espera? ¿No te deja?
Oh yes, we will send you to the waiting room. So
Okay.
Good idea.
Lo importante es el tema de la conexión.
Sí, Cristian.
Cristian debería ver eso. Cristian, si estuviera por ahí.
Sí.
Momento.
Cristian, estamos dejando a Fernanda en la sala de espera, pero no hay que aceptarla que vuelva todavía. Fernanda, welcome back. Great. Yes, can you hear us, Fernanda?
Creo que está sin micrófono. Ahí viene su...
Sí, tiene dos sesiones distintas.
Sí, una para video y otra para audio.
Sí. Fernanda, can you hear us? ¿Me escuchas? Nosotros no te escuchamos. ¿Tú no escuchas?
¿Ahora sí?
Ahora sí.
Sí, ahora sí.
Yeah.
So thank you for all the short waiting. So now we're live. YouTube, I think, for comments. So, as a president of this committee member, we are very happy with your presentation. We evaluate as independent the written part and the oral presentation itself. And for the written part, the committee decided to give you a 98 degree, and the oral presentation 100. It was a very good presentation. We give you a final grade of 99. So we congratulate you as a new master in computer science of the Departamento de Informática, Universidad Técnica Federico Santa María. So we are very happy with your work. And
Thank you very much.
aplausos.
Thanks.
Congratulations, Fernanda.
Thank you, Angelos. Thank you, Profe Marcelo. Really.
Would you like to say some words?
I don't know. Thank you very much. I'm very, very happy, really. And thank you for everything, really, Marcelo, for everything, the meetings, the ads, for everything, and also Evangelos for receiving me in Canada. It was amazing. And well, also, always thanks to my mom, obviously, and my family, my friends, my boyfriend, who is a real support of each other. So I don't know, thank you to everyone, and I'm really, 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 really happy.
O puedes decirlo en español también, si gustas.
Tampoco sé qué más decir.
Bueno, so let's all face the camera, so I can take a picture to remember this moment. Please make your best smile. Okay, very good. 2 pictures. Now we don't have a drink, which is the tradition, but we will have some when we come back. At least Marcelo, when we come to the non-Zoom live. So it is an excellent Christmas present. So after all your work.
Yeah.
Felicitaciones, Fernanda. Muy buen trabajo. Un proceso largo, con varias dificultades. Nadie esperaba de que tuviéramos una revuelta y después una pandemia.
Oh, sí. Sí, fueron 2 golpes bastante.
En este escenario tan complejo y con tanta incerteza, en realidad tiene mucho mérito. Así que felicidades, familia, muy merecido el grado que obtienes. Y adelante, sigue trabajando y avanzando lo más que en el desarrollo profesional y académico.
Lo haré, profe, no lo dude. Muchas gracias.
So thank you very much to all the members and to Fernanda and all the people who is online watching this defense. So this is almost noon 03. So this is the end of these 2 long hours and very interesting presentation. So thank you to everyone and bye.
Bye, thank you.
Quedo esperando el documento, Claudio, entonces, para firmar el